Okay, these are Thursday's notes, and this will help you with your assignment 4A that's due on Friday. First of all, a little side note. If you'll remember that x to the negative 2 is 1 over x squared, or 2 to the negative 4 is 1 over 2 to the 4th, or 1 over 16. However, this is notation. This is not an exponent. This is notation that just means f inverse, or inverse function. Okay, so same thing with trig functions. So the first one we're going to talk about is the inverse sine function, which can be written as inverse sine like this, or another way of writing it, which means exactly the same thing, is arc sine. Don't let that throw you off. It just means the exact same thing. Now remember, inverse just means to undo, so if I had the square root of 3x, I could use the inverse, which is the quadratic, the square, to undo that square root. And they would just cancel each other out. So it's the same thing with trig. If I have the sine of 3x, I can use inverse sine to undo that sine function, and I would end up with 3x. So it works the same way. Now let's look at the sine graph. Okay, you've got pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, and so on. Now this graph, this is y equals sine x. This graph is obviously a function. It passes the vertical line test. It's one of your trig functions. The question that I gave all my classes is this graph 1-to-1? Well, it is not 1-to-1. If I run a horizontal line test, it obviously fails that test, which tells us that the inverse of this sine graph, the inverse is not a function, because the inverse graph would be the same wave, but it would go vertical, so it would no longer pass the vertical line test. So what we have to do, we have to restrict the domain. So we're going to grab a part of this graph that is 1-to-1. So we're going to use the part from negative pi over 2 to pi over 2. From here to here. Which, if you think about the unit circle, it's just the right side of the unit circle. From negative pi over 2 to pi over 2. So you've got all these angles in here, our common angles, pi over 6, pi over 4, pi over 3. Remember that these have coordinates. That's 1/2 square root of 3 over 2. You can use the hand trick to get these if you don't remember, which you should remember because we've done this a lot lately. There's a pi over 4, square root of 2 over 2, and so on. Here you've got 1, 0 right here. You've got square root of 3 over 2, negative 1/2, and so on, all the way down to 0, negative 1. So, if you see a problem that looks like this, arcsine 1, you got to remember, just like the inverse functions that we've used in the past where we switch x and y, here we switch the angle and the value. So the arcsine of 1 is going to equal an angle. So what this is asking is telling you to find the angle where sine is 1. So where is sine 1? Remember, sine is your y value. So right up there at pi over 2, the sine is 1. So arcsine 1 is equal to pi over 2. And that's how inverse trig works. Sorry, let me move that up for you. Arcsine 1 equals pi over 2. Here's a few more for you. Remember, arcsine and inverse sine just mean, this is the same thing. Inverse sine 0, so at what angle is the sine 0? At 0 radians, or 0 degrees. Now here's an interesting one. What is arcsine negative 1/2? Well, it's right there, but everybody wants to put 11 pi over 12. But you can't put 11 pi over 12 because 11 pi over 12 falls right here on the graph. We need to give an answer between negative pi over 2 and pi over 2. So the proper answer here would be negative pi over 6. Okay? And then the rest of them are basically the same. You've got the inverse cosine. Which inverse cosine, we're going to use this part of the graph from 0 to pi, because that part right there is 1 to 1. Which is the upper half, quadrant 1 and quadrant 2. So an example here would be, what is the inverse cosine of 1/2? That would be pi over 3. In other words, at what angle is the cosine 1/2? So that's right there at pi over 3. And then the last one is the inverse tangent. If you think about that graph, get an asymptote right there at pi over 2. You've got an asymptote right here at negative pi over 2. And you've got another one over here at 3 pi over 2. and this graph just continues. Well, it's not continuous, but it repeats. The period is pi, and then it just keeps going. So we're going to use just this part right here. Because if I go past pi over 2, then it will no longer be 1 to 1. So again, we're just talking about the right side of the unit circle. So sine is the right side, cosine is the top half, and tangent is back to the right side. Now remember that tangent is sine of theta over cosine of theta, which is y over x, which you've heard me say numerous times. It's just the slope. So if you see a problem like this, where you're finding the arctan of 0, that's asking at what angle is the tangent 0, or at what angle is the slope 0. Well, the slope is 0 right here at 0. It's a horizontal line. The inverse tangent of -1, where is the slope -1? It's right there, that part of the graph, which would be negative pi over 4. Remember, your answer has to fall between negative pi over 2 and pi over 2. So you can't say 7 pi over 4. That doesn't work. And then you've got some, when it comes to the common angles, you have some weird ones here. So the arctan of square root of 3, that is where your sine is square root of 3 over 2, and your cosine is 1/2. So where does that take place? Let's see, right up here at pi over 3. So the arctangent of square root of 3 is at pi over 3. The other one that you'll see that's a little different is the inverse tangent of square root of 3 over 3. See, that would be 1/2 over square root of 3 over 2, so this one would be at pi over 6. So lastly, on your homework, you're also going to see some problems like this. I've had some people asking questions. So let me show you one of these real quick. Let's say that this is x, this is 4, this is 12. Okay? And you're asked to write an inverse tangent function that would solve for x. Or just an inverse tangent function. So usually we would say that the tangent of the tangent of theta is opposite over adjacent. Well, an inverse tangent function would look like this. So that's what they're looking for. You set the angle equal to inverse tangent. Okay, there's your lesson for you. That'll get you through homework 4A on page 349. Thank you.